Good morning. How's everybody doing? You're all very brave travelers for making it out to Caesar's Forum on a Friday. I bet Garrix is amazing, though. Well, thanks for making it out. I hope everyone had a great reInvent. So I'm here to do something a little bit different today. We don't often do these kinds of talks, so hopefully it's the first of many. But my name is Abby. I'm a senior principal security engineer at AWS, and I mostly work on security for EC2 and friends. So EC2, EBS, API Gateway, and Amazon Linux. But on top of that, along with a handful of other kind of security-minded senior engineers, I also work on a cross-AWS team that we call Ghostbusters. So Ghostbusters we use as kind of a security big red button. So we handle escalations, we help assess the impact of issues, we help SecOps, who we'll talk about in a second, figure out what the right path forward is with service teams, and we work with service teams on what an actual fix or mitigation might look like. So in events like Log4Shell, we often end up leading the response. So more on that in just a couple of seconds. I got really excited about animations, by the way, this year, so we'll see if any of them actually work. But before we get into Log4Shell, it's worth talking in a little bit more general terms, kind of how we think about events at AWS. So most event response, whether it's for a security issue or for an operational issue, it takes place on fancy conference calls. And that ends up looking something like this, right? So there's a TOS call, so the tech operations call. And that's focused, regardless of the event type, on mitigation and recovery. You'll notice that you don't see root cause on there. And we've covered that in a couple of other operational talks. But the TOS call, you just focus on fixing the problem. You focus on immediate recovery. You focus on fixing it. And then generally, we get to root cause a little bit later. In parallel, there's a second call called the dashboard call. And I've called that the everything else call. But that's focused on things like customer messaging or the service health, right? So things like dashboard posts. But these conference calls, they're a little bit different, right, than a regular work call. So event calls for operational events are run by call leaders. There's only one call leader at a time, and they're responsible for kind of all of the tactical parts of the event. So do we roll back a deployment? Do we wait out of an availability zone? These calls are also supported by a group called Tech Operations, which is where the TechOps, the TOS call name comes from. And they're responsible for kind of event support. So paging other teams in, kind of maintaining general order. If you work at a company like AWS, you've probably heard the please mute your line while not actively speaking, right? And the TOS call folks are the ones that are making all of that happen in the background. So on a security call, things work just about the same way. So under ordinary circumstances, security response at AWS is mainly handled by security operations, so called SecOps. So these folks are global. They're staffed 24/7, so they follow the sun. So whenever you send a ticket to AWS security, so to SecOps, you get someone that's awake during their daytime and on shift. It doesn't mean, and we'll get to that later too, that you won't end up paging in someone else, right? But you always start with someone who's awake during their own business hours and is ready to be there. So what that looks like kind of in the normal kind of flow of events is something like this. So you cut a ticket to SecOps, and it's a potential security issue at this point. Maybe you know something happened. Maybe you know there was a potential for something to happen. But it can be by a service team. It could be a customer report. It could be automated through tooling. Doesn't matter where it comes from. But that ticket gets triaged by SecOps. And then SecOps, they look at that ticket, and then they engage escalation where they need to. So in a lot of cases for security events, that might be someone like the Ghostbusters. Then SecOps engages a service team, right? So the SecOps group and the service team, they work together. They align on what the actual risk might be in any given scenario. They talk about urgency, propose mitigations or fixes or deployments. They work out things like customer communication, right? Do we have to let customers know about something? And then the service team is responsible for completing any of that mitigation, like getting a deployment out, engaging leadership, right, writing customer messaging. And then SecOps is responsible for kind of driving that event through to completion. So did the action items get done? Did messaging get approved and then sent? Did the fix actually complete? Did we assign COEs, right? So one of the kind of founding principles, right, at AWS for how we handle events, operational or security or otherwise, is that you're serious until proven otherwise, and not the other way around, right? You start with the assumption that something is a big deal, and then if you can prove that it's not a big deal, then you can downgrade, right? But other than that, you treat everything like it's a big deal right up until you can prove that it's not. And I think that's really important, right? Particularly in security issues, because you get a lot of exercise, first of all, of the process if you're treating everything like it's critical, right? So first, you get a lot of practice in the process. So if something like Log4Shell does come along, it's a really well-trodden, well-exercised path. It's not scary. It's just kind of, here's how we normally respond to events. I'm not going to go through the whole flowchart out loud, but this is roughly how we triage an event, right? So it comes in, you make a sort of rough assessment of what is the potential impact here? Is it nothing, right? Like, is it a false alarm? So lots of tickets come through where it's like, I saw on Hacker News that this package had an issue. And sometimes there's a really easy first step, right, which is we don't use that package. And then it's done, right? And we want to verify, right? You want to make sure that no one uses that package anywhere. But sometimes there's a pretty easy kind of first step where you can rule out how big of a deal that event might be. But when it's not, then there's kind of a second layer that you go through. And that's the big deal until proven otherwise. So that might be paging in someone like Ghostbusters. That might be starting a TOS call. That might be working with builder tools and the service teams to figure out like what the blast radius of a library or a package might be. But generally, you can follow that same kind of series of events for every single type of issue, whether it's a Log4Shell or kind of a false alarm like Nothing Burger, right, or an operational event. Comes in as a big deal. You see what you can weed out. You see what the actual real-life impact might be, and then you can follow the steps accordingly. But sometimes, things aren't quite normal circumstances. And it doesn't mean that the process doesn't apply, but it means that how we do it is a little bit different. So if you take Log4Shell or something like Log4Shell, and we'll get into specifics in a second, Ghostbusters might run the event. So it comes in through SecOps or through a ticket or through a customer report the same way as anything else. But when you get to a point, right, where SecOps says, you know what, I think this actually, there might be something here. Ghostbusters often can take over that TOS call, can take over running that event until we're able to kind of get a better sense of what the potential risk is. And I think this is something that I think is really important about how we handle security issues. And I think that's kind of the putting the money where our mouth is on treating everything like a big deal until proven otherwise. The Ghostbusters is a pretty heavy-hitting team to be running a TOS call, right? So it's mostly senior principals or distinguished engineers. There's a handful of principals on there. But it's a big hammer. And having that group of folks, right, coming in on a weekend or at 2 a.m. to lead a TOS call, I think is part of what backs up how seriously we take issues like this, right? That we're putting some of our most senior security folks on the line to kind of make sure that everything goes exactly the way that we want it to. And it's good for SecOps, right? Because they get some backup for things like calling people at 2 o'clock when maybe they aren't super excited to be called at 2 o'clock. But it's good for all of us, right? Because you're putting a little bit of the heavy hitters behind kind of how seriously we take a potential event. So once once Ghostbusters comes in to take over this task call, things end up kind of shaking out the same general process, but there's a couple of different work streams that happen once an event feels like it might still be a big deal, a certified big deal. And that might be things like, is there a fix available? And if there's not, we start breaking off parallel work streams, right? So folks work on building and testing a fix, while other people work on assessing impact or trying to reproduce whatever the publicly reported issue was. And then in parallel, we have folks that are working on coordinating the event itself. So paging in teams, trying to assess actual impact, tracking progress, right? Once we start figuring out who might actually use an impacted package or library. And then there's a third parallel track, which is focused on communication, right? So that's like the dashboard call that we spoke about a few minutes ago. But they're working on, what do we need to tell customers? Do we need to get things like security bulletins out? Do we need to get harbingers out, or personal health dashboard notifications, right, that you see in your AWS account? And at some point, all of these threads will end up converging, but being able to parallelize the response is really important, because it means that progress on one kind of component of the response isn't coming to a halt while you write messaging or a dashboard notification. You shouldn't be kind of paused on progress for a fix or getting ready for deployments. So Log4Shell, right, or in our hypothetical examples, they're not the first time that we've had to respond really quickly, or where something's been kind of a all hands on deck sort of big deal. So some of you might recognize the little logo that popped up in the bottom. So back in 2014, there was something called Heartbleed. And Heartbleed was a memory disclosure issue in OpenSSL. And this impacted a feature in OpenSSL called heartbeats. So heartbeats are for things like keep alives. And they let a sender request a specific response from a receiver. So the Heartbleed issue, though, will let you get back the payload and the length, plus whatever the buffer was in the memory associated with the length of that response. There was no bounds verification. So if you work on security issues, that's maybe an interesting flag for you, right? You're not checking how much memory should be returned with that length. And not verifying things leads to all kinds of really interesting issues. So that was part of Log4Shell as well. But ultimately, Heartbleed let you return a payload with a really large length and return the corresponding kind of chunk of a memory buffer. And because this was memory that OpenSSL had used previously, you could get all kinds of fun stuff this way. So private keys, usernames and passwords, certificates, and importantly, right, Heartbleed let you continue to kind of hang out and eavesdrop on whatever your target was until both the bug was patched, but also all of the associated material had been rotated. So simplified, though, Heartbleed ends up looking something like this. So my initial request, right, I might say, hello, so give me back this phrase, open sesame, if you're listening. And I expect open sesame to be 10 characters long. And in a normal TLS heartbeat request, right, I'm listening, and it sends back open sesame. With Heartbleed, I can say, hello, say open sesame if you're listening. Open sesame is 122 characters long, which it's not. Counting is hard on the Friday after reInvent, but it's not 122 characters. And what I get back is, I'm listening, open sesame. And then whatever the 122 characters were from memory, right? So in my case, user Beetle, an administrator, wants to set the server master key to admin. User Eric wants to set the user password to hunter1. And you'll notice from just this example, right, and this is simplified, but Heartbleed was simple. Heartbleed was simple. It was simple to use. It was simple to get back interesting things. And that's part of what made it such kind of a mad scramble for folks on the internet, right? So for AWS, we had to hot patch. Ultimately, 2-line fix but millions of deployments. And we did this in hours, but at night, right? So at night, 2-line fix, millions of deployments, and for the first time, right, we scanned the entire Amazon EC2 IP space so we could send notification emails to every potentially impacted customer. If you've ever received an email like this, right, it is chaos because we err on the side of potentially and not definitively impacted. So generally, when we're sending notifications to customers for things like this, we're saying, hey, there's something out here. It might be something that impacted you. Go ahead and look. So we're indexing on how can we give people the earliest possible warning, right? Even if it means it's a false positive. For more info on Heartbleed, Colum McCarthy did a tweet thread on the Heartbleed anniversary back in 2019 on how we handled the actual hot patching and deployments and customer messaging. That's on Twitter. So I recommend checking that one out if you have some follow-up questions. But even Heartbleed, right, that's not the end of it. And over the last kind of decade, right, we've had an increasing number of kind of mad dashes like this. What was unique about Heartbleed and Log4j, now known as Log4Shell, right, what was different about those is that they were easy. They were easy to exploit. They were easy to take advantage of. There was no like special micro architectural knowledge required, right? So a lot of, in the last couple of years, what we've seen has been things like side channels. Those are not as easy to exploit, right? They require having generally some amount of specific knowledge. It's fairly specialized. It's generally not super easy to take advantage of things like microarchitectural side channels or timing side channels, right? And Heartbleed and Log4Shell, they weren't like that. They were really easy. But some frequent flyers, I think, that we've spoken about probably a number of times, and I think those logos are probably familiar to a few folks sitting out here. But so far, right, we've mostly covered just what the reactive part looks like. So when a ticket comes in or when a potential report comes in, how do we respond? But proactive element here too, right? So both being able to know when something might be coming or when you're able to identify when something kind of might be exploited. And the reactive part, I think, is often what's interesting, right? Like that's the event part. That's how things like, how did AWS handle Log4Shell? But there is a proactive element too, because that proactive element is how we don't do this more often. I had fun responding to Log4j, but I'm not sure everyone wants to do that every week, right? So the proactive element is just as important. So can we predict when something can happen? So more often than not, we think that we can. And a lot of that is just kind of detective work, right? So you're looking at a CVE feed or a mailing list or researcher reports or papers that folks write for conferences. There's all kinds. But ultimately, it's just kind of, it's poking around. It's reading reports. It's looking at a feedback loop. It's seeing, okay, so I learned about this one thing 2 weeks ago, and now this new report is out. Can I do anything with both of those? Does it go from being kind of one, not that exciting issue, to a really exciting issue with information that I know now? And a lot of the security teams call that things like pivoting, right? So from the information that I have now, what else can I get? And if I can get information from kind of step one, what can I use the information that I got from step one to find something at step two that maybe is a little bit more exciting? And those different data sources, right, are what makes things kind of long-term interesting. So with something like Heartbleed or Log4Shell, can we figure out whether something was exploited, right? And it's harder. Some issues are harder to tell whether there's any sort of like little, so one of the industry phrases for this, right, is indicators of compromise, right? So an IOC. Can we find any kind of breadcrumbs that something might have been taken advantage of. And what's interesting, for some of these these bigger issues, so side channels or Heartbleed or Log4j, it's not always really obvious. So you're putting together a lot of secondhand breadcrumbs as well. So to our friend Log4Shell. So before anything even kind of kicks off, what was Log4j anyway, right? Why did this end up being such a big deal? So there's two kind of characters here that I think are important for this conversation. So the first is Log4j itself. Ultimately, it's a logging library for Java. Lots of people use it, and we'll get to that in a second. But Log4j, it lets you log different levels of information from inside your application. So that could be something like user input or an HTTP request. So JNDI, so the Java naming and directory interface, right? This is the other kind of component in our cast of characters. So it lets Java applications look up things like an object or a name at runtime. And there's some functions for JNDI out of the box, right? So DNS or LDAP, which we'll get to in a second. So Log4Shell, I think we now know a pretty solid timeline here. And I think if you're looking at these up on the very large screen, you might notice a couple of pieces that stick out for you. And notably, it's that the initial report of the issue that led to Log4Shell, right, was November 24th. And a lot of folks had different responses here. But how many of you responded to Log4Shell? How many of you responded to Log4Shell on November 24th? Yeah. So I think you'll see on the timeline, right, as well as like what happened in real life, that not a lot of folks were doing anything on November 24th. We were living a very different lifestyle. And we'll go through this whole timeline in just a second. But the place we want to start is November 24th, right? And that's kind of where our story picks up. And that's when Alibaba reports the very first Log4j issue that we now know as Log4Shell to the Apache Foundation, so the maintainers of Log4j. And this is it. This is the first one. And basically, right, you can use parts of the JNDI tool, so the Java naming and directory interface. And it doesn't kind of control against input that you don't want, basically. And what that means in kind of plainer terms, right, is that if I can control log messages, or if I know that messages passed, that parameters passed as part of a logging message, if I know what you're doing with those, I can use them to execute arbitrary code from wherever I am, right? So remote code execution. So this is what that looks like, right? So really simplified, I can use that JNDI lookup feature to execute code. So I can pass things like an HTTP request that I know will get evaluated, so looked up, right? And the JNDI naming for things. And I know that they'll get logged at runtime. So ultimately, what Log4Shell came down to, those inputs weren't validated. And I think a lot of folks have seen the XKCD comment, right? Where it's like, and I hope you've learned to sanitize your user inputs. No, we have not learned to sanitize our user inputs. And ultimately, that's what this looks like, right? So a lookup, something like the super secret key. And the JNDI lookups, exactly the same way. However, we've made a lot of tools in general, right, for software that are to make our lives easier. And that's things like remote lookups. And I don't necessarily feel like in this case, remote lookups ultimately made my life easier. But in general, right, for day-to-day development, they do. So that's a little bit about what this looks like, right? That's what a remote lookup with a JNDI plugin would look like. So on November 29th, right, the Apache Foundation publishes the first and second fixes for that original issue that was reported by Alibaba. And if you work on a lot of security issues, you'll notice that they look a lot like this in general, right? The fix for this, the commit message for the patch itself, it's pretty boring, right? There's some trigger words in here if you read a lot of these, but it's basically just saying, hey, don't worry about this. We just don't format lookup by default. No big deal. Don't worry about it. But from November 29th, right, when Apache published those fixes, until the first tweets started appearing on December 9th, pretty much under the radar. They don't get a lot of attention. There's some activity later that we now know on some forums, most of which I could not read. But these are pretty casual. You don't see a lot of attention. But where things start to pick up is December 9th. And for us, that's kind of like Log4Shell day one, right? This is when everything kicks off. So what this looked like on the AWS side. So at around 7:40 Pacific time, the first Twitter mention of a potential Log4j issue pops up. This isn't ultimately the first, but it's the first that picks up kind of general publicity, so general steam. And this catches people's attention, right, for a couple of reasons. So one, it references an RCE, right, so remote code execution. And it doesn't specify a specific version of Log4j, right? And usually, if you write messaging for security issues, you want to scope it down as much as possible. This doesn't do that. This just says Log4j, right? And it says Log4j too, and we'll talk about that in a second. But it doesn't specify a point version, not like Log4j 2.08, right? It just says Log4j2. And we have bonus points here, and that Log4j is incredibly, incredibly widely used. A lot of people have Log4j. And it's one of those things that's kind of a little sneaky, right? And that it's the dependency of a lot of other tools. So it's in a lot of places. So at 7:40, when he sees this tweet, Mark Brooker, cuts the first ticket to Ghostbusters. And it is pretty vague, right? This is the first one that we started running the event out of. And there's a couple of others that we found then a little bit later of folks that had seen a forum post or someone had sent them a Slack message. But this is the first one that kind of triggered this might be a 5-alarm fire sort of situation. And then you can see this is from Mark's actual ticket. I don't know any more about this than what the tweet says. If this is true, a Log4j RCE could be a pretty big deal. This is called foreshadowing. Thank you, Mark. And this is actually really interesting, right? And it is extra important because we don't actually know at this point if this is true, possible, anything. We don't know if this is this is a nothing, could be anything at this point. But we now know, right, more foreshadowing. It was not a false alarm. But we treat these like they're a big deal otherwise. And I've already spoken with Mark about this. Not a stellar security report, but we work with what we have. So at around 11, Column notifies Steve. And you'll notice that that's a pretty short time window from the first kind of we don't even know ticket coming in to telling the most senior security person at Amazon, really short window, right? At about 3 p.m. Pacific time, there's the first formal briefing for the rest of AWS senior leadership. And ultimately, we ran these briefings twice a day for the first probably 10 days of the Log4j response, which is expensive, by the way, especially on holidays. They don't love that. Guys, animations are awesome. So at around 11:48 Pacific time, again, I apologize to my coworkers who don't run in Pacific time, but it was the easiest for an in-person conversation, and I'm sure I'm going to get a lot of messages about it. But at around 11:48, right, so not long after that first ticket comes in, and Just about 48 minutes after Column tells Steve, our first set of mitigations roll out. And that's a couple of the ones we started with. But this was even before we started to understand the full picture. And these were proactive. And these were a big swing at, if this turns out to be a big deal, what can we stop before it becomes a big deal? So this is a set of traffic filtering rules. And the goal here was to catch any potential exploit attempts, what we thought an exploit attempt might look like. So these are request matching patterns that can be kind of ingested by tools like WAF, so Web Application Firewall. And we ended up iterating on these rules and lists of patterns throughout the whole beginning part of the response, but that's where we initially started. So at 122, Ghostbuster starts the first toss call. That's me. And in the end, that actually, by the way, that icon is what I use on my actual phone for toss, is the little skull. I think that's nice. So that's the right message. But at the end, that first call, so the first one that we started on the very first day, it doesn't stop for 3 days. So at a little bit later that first, right, so Ryan Schmidt from Builder Tools proposes the first internal patch. And this just removes the Jindy lookup class entirely, just blows the whole thing away. This is also foreshadowing, but this is incredibly smart by Ryan, and it ended up paying off in big ways for us, right? And it was really important for the rest of our response. But Ryan made the assumption from the beginning, we almost always find new issues with an issue that's reported like this. It's never just the initial report. Someone always sees that little breadcrumb and says, I should poke more at that. I should poke more at that. I should poke more at that. And before you know it, you're fixing, hypothetically, 4 additional CVEs. So we blew it away on the first day. So right about now, we start doing our internal builds. The AWS fleets, for what it's worth, are very large. So this is a big process. So about 148 builds start. And we keep those same kind of traffic filtering rules in place. So at around the same time, right, on the toss call, we decide, well, we're here. We should also just get V1. And you'll notice that back in that original tweet, right, it just said V2. And in the spirit of better safe than sorry, right, so just like disabling that entire class from the beginning, this also pays off. So we just decide to extend the mitigations to V1 and V2, even though at this point we have no indication that V1 is actually impacted. So we talked a little about this in the abstract, but typically the event response kind of follows a really standard pattern for AWS. So the first one, mitigation, stop the bleeding. Can I prevent an issue from getting worse? Or can I prevent new occurrences, right, from happening? Second, detection. Can I tell if this happens again? If someone can exploit this, will I know? Are there warning signs? And next is prevention. Do I know what the root cause was? Can I close whatever gap led to this issue happening in the first place? And then the very last step is cleanup, right? Can I identify and fix any existing impact? Can I fix what's already happened? And at this point, we have our kind of initial mitigations in place, and we have a patch that's under review, right, from Ryan. And it's time to look at what the kind of long-term detection looks like. And that means that our next question is, if there are attempts to leverage Log4Shell, can we catch them? And we think so. So we spin off a handful of AWS security teams at this point to start to look at this. And this is roughly what that looks like, kind of, again, at a really high level. So first of all, if our patch is efficient, does it catch everything? Do we even know what an exploit attempt would look like? And then, if we know what an exploit attempt looks like, if we know what an IOC is, can we use that as a pattern to find anything similar? And then you can pivot from there again and say, are there common IPs? Are people trying to exploit that? Are they coming from the same place? Do they have something else in common, like their formatting, their attempts or requests in a similar way, right? Because you can often track those down to the central source, right? That someone posted a proof of concept online, or they posted a tool for trying to exploit Log4Shell online. What else do those IPs do? If they're trying to exploit Log4Shell, what else are they up to? And then you can keep feeding that cycle over and over and over again. And this is one of the first branches off of that main call. And actually, the work from this, I hope that they do a talk on this at some point, just on its own. But it ends up being incredibly cool. This work is incredibly cool. And by the end of kind of the initial kind of first period of event response, this tooling that was created on the fly on one of these offshoots of the main call blocked over 2 billion attempts to leverage the Log4Shell issue against AWS services. And the team is able to do this by working on things like internal Java profile data, a number of our kind of existing threat intelligence sources, and it let us kind of identify and proactively block traffic that might have potentially led to an exploit. So at this point, we've got our mitigations in place, we've got our patch under review, we've got our detection happening, and we want to roll on to actual prevention. So what can we do with the information that we have? So at around 3:30, we start mass deployment prep for AWS teams. So this is with the built patch that we talked about from Ryan. Again, AWS is a large place, so these fleets are in the many, many, many millions. And building this many environments briefly gives the build system the hiccups. And in parallel, work starts on a campaign. So campaigns are what we call it, but things like mass waves of tickets. So how do we notify teams that there's an action that they need to take, potentially that's an emergency? So these tickets go straight to service on-calls, so people get paged, and it instructs them to, once patches are built, they need to work out getting deployments out to their services as quickly as possible. This is the first of many, but this is what a highlight from the first campaign looked like. So I've mentioned a couple times that AWS is very big, right? What happens when you have to prioritize work across so many services? And some of you might remember, right, that like things at the holidays always have a little bit of an extra element to them, right? People are on vacation, people are traveling. So, and we can talk about this a little bit later too. And I think both Cullum and David Janacek have covered it in talks this week as well. But we also have things like change control. So that's things like not pushing out a lot of deployments when people are trying to get their holiday shopping done, hypothetically, right? So there's work that has to happen when we have to prioritize this much work across this many teams. And it was really clear at this point, right, that we've blown away the whole class and we're going after V1 and V2. So the approach here at this point is basically you patch everything. Even if we don't think that there's a chance that this could actually be an issue, even if we think all of the other mitigations are sufficient, it doesn't matter. You have to patch anyway. But there are some constraints, right? You can't just kind of patch everything right out of the box. So the first is people. We have limited people. People are on vacation, people are on holidays, people were on call for things like December 7th. Availability. We can't take any availability risks, even though we have to get a lot of work out for a potential security issue. And this is kind of an evergreen bit of tension, right? So you always have to weigh security versus availability. So our thought process here ends up looking something like this, right? We want to balance urgency with risk. So urgency with availability, or with what we think, the potential impact for a service would be. So the first one, we prioritize network-connected services that directly take customer input. We also prioritize things that have extremely large fleets, so things like EC2. We also prioritize services that we know take a little bit longer for deployments. So that's things like state services that have particularly strict durability requirements, so like EBS. And we also prioritize in that first wave dependencies that are common between many services. If anyone's ever gotten a ticket, right, to patch something or to do work on a service, only to find out that one of the underlying dependencies hasn't been fixed yet, right? It's not a great experience. So we have to make sure that we can identify those early dependencies first. Second, we go after network connected services that don't directly take customer input. And we go after container images and Lambda functions, right? Or network connected internal only services. And that leaves our third wave for non-network connected services, or things like developer desktops or test environments or not very common dependencies. And this all helps kind of control what the load on people and systems and services ends up looking like. But just the coordination here is a massive effort, right? So this means engaging tens of thousands of resources and tickets. And with resources, I mean humans, right? It's tens of thousands of tickets. You're paging tens of thousands of humans, right? That is tens of thousands of on-calls of people that were paged and woken up, and we've asked them to do work. And all of those folks are going to have questions, right? So running a good campaign like this means also having good documentation. So are there clear and easy to follow directions for resolving the actual issue? That means if I'm paged at 2 a.m., does that page say specifically what I need to do? Is it easy for me to follow? If it's my first time, God bless me, on call for a service, can I follow the instructions in that page? Is there a clear wiki? Is there a channel where I can go to get help? And for most of this event, right, we ran a number of support channels that ended up being staffed by folks like Builder Tools or SecOps or Amazon Linux or the JDK folks. And these channels were busy. This is not the peak of one of the channels. This is just when Abby remembered to take a screenshot. But this is a massive effort, right? And so on top of the folks that you're engaging as on-calls, that means who's working the support channels? Who's staffing all of the questions? Who from Builder Tools is working at night in case the build system has an issue? So at around 7 p.m., change control takes effect. So to handle the volume of upcoming builds and deployments, we implement change control. And that basically stops all other builds and deployments to prioritize work for Log4j. Generally, that means that you have to get pretty far up into senior leadership to get approval to deploy something that's not relevant, right? So in this case, and often that means nothing, right? So for a lot of things, for a lot of change control, it means there are no deployments. And in this case, it means only Log4j. Only Log4j builds and deployments are going. And we actually went in and stopped all of the other work. So we stopped people's builds for them if they were not Log4j related. All of this work, right? So we're making a very conscious choice that, like, this is important, and we are going to make sure that it is protected because it is important, right? So we'll go in and take action for folks. At around 8 p.m., the team that's responding to the event, so in this case is Ghostbusters, right? We start to engage large teams directly. This one is me, but one of the kind of the benefits of having really distributed teams, as in Cape Town and Seattle are just about as far apart from each other as you could possibly get, we start contacting the large fleets. So EC2 is still mostly split between Seattle and Cape Town. We have folks in Dublin, we have folks in New York, but the vast majority of like the EC2 control plane services, things like run instances, what happens when you launch an EC2 instance, those folks are in Cape Town. So we take advantage of this, right? And we totally monopolize the build system during the Cape Town daytime, which is Seattle's nighttime. So ultimately, the vast, vast, vast majority of Amazon EC2 services patch that first night while Seattle is asleep. December 10th. See, we're only still on the first day. Well, this is the second day now. It was a big day. So Log4Shell day 2, just a quick hack. So Seattle comes back online the next morning. And at 2 a.m., Volker Simonis from the Corretto team had tweeted a Log4j hot patch that let you, and a hot patch in this case, it let you patch a running JVM without a restart, so to patch in place. For posterity, that is the original tweet. Then the new permanent home of the hot patch, which ended up hanging out with everyone for quite some time. And then the very first internal proposal. So on the 10th, at around 7, right? So the Seattle crew is back on shift. We worked all day on the 9th. A couple of us got a couple hours of sleep. We're back online, and we wake up both to that Volker has tweeted his patch and that S3 has been testing in earnest to see what they can do with the live patch alongside the main one. And at this point, we decide that we need to fork our efforts a little bit, and that we'll split off a group to look at what can we use this live patch for in parallel to the regular patch. And then we keep the existing group going on what kind of the main patch is, the standard patch, so removing that whole class. At this point, right, and folks that respond to security issues might have also seen this, but the stuff I do is easy. Responding to the initial security event, figuring out what's happening, that's easy. Everything else is hard. There are so many pieces here to responding to an event that are not the initial with, oh my God, look, a CVE, it's rated 9.8. That stuff is easy. This stuff is hard. And that's things like, do we know how to report on progress? How can we tell when we're done? Have we gotten all the dependencies? Is the build system okay? Have we tested all of this? There's an incredible amount of kind of unseen secondary work that goes on, where the response doesn't stop at that first TOS call. So at 11, we start kind of the second wave of big deployments. And all Log4j, all non-Log4Shell builds and deployments, they're stopped. And this is now for the second wave. And then just like that diagram that we just looked at around 11:30 on the 10th, we get to the, we have a patch, now what stage of event response. AWS is big, so making things happen requires some special skills. So at this point, we engage LoRa, right? So how do we get things moving in the right direction? How do we track dependencies and progress and blast radius? But you can't catch a breath, because at around 7 p.m., the second Log4j CVE drops. And this says that some non-standard configurations are still vulnerable to an RCE if they use the JDBC depender with LDAP, basically. Since we removed the Jindy lookup class entirely, this was covered in our existing patch, so AWS is not impacted. At this point, we have our 2 parallel work streams going. And on the 11th, we start to look at rolling out that hot patch, so that live patch from Volker, at the same time as the main patch. So we've worked on this at this point for a couple hours, and we think that we have a safe strategy to roll out so many parallel deployments. And at around 3 p.m., we start picking up speed. So the way that deployments work at AWS is that we never roll out to multiple regions at the same time, right? It's a safety mechanism. So by 11, we started testing some regions. We started rolling out the hot patch in waves alongside the regular patch. By 3 p.m., we've seen that it's safe and that we don't see a big impact. So we've made it through multiple regions, so we start pushing the hot patch out in earnest. And now that we have LoRa kind of on the job for helping us figure out all of the hard things, like how do we know when we're done, we start looking at things like stray dependencies, stray ECS tasks, developer desktops, and that that ends up in our third wave of tickets. And it's mostly, at this point, for ECS tasks. So if you've run ECS before, tasks are what has like the associated container definition with it. So what's inside my container that I'm running on the ECS Elastic Container Service. So our hot patch rollout, though, does cause a brief issue. So in some cases, rolling the hot patch caused some small transient spikes in latency. And it's worth noticing at this point that we didn't ask teams to deploy the hot patch on their own. So we did it for them. This is really unusual for us, right? Generally, like teams at AWS, they are responsible for doing all of this work. They have to get out the patches and the deployments to their services. And in this case, teams were still responsible for that main patch, but for defense in depth, we deployed the hot patch in parallel on their behalf, so at the same time. So from the 11th to the 14th, patching work kind of continues. We track down some stray tasks, we track down stray functions, we fix developer desktops. And then it's time to start looking at our kind of our fourth step. I've patched, and now what do I do? So at around 7 p.m., right, we start kicking off what follow-up investigations look like for service teams. So we split off, again, another separate thread from the main group to start helping service teams with investigations. So that's guidance for how teams know when they're done. That's to help them pull their service and application logs. And that's to help them sort through any of that data that we get to see if there's any new information that we can use to drive more mitigations or detections. Lambda. How many folks use Lambda? So Lambda was an interesting one. Lambda doesn't include Log4j in any of its managed runtimes or any of the base container images. But Lambda customers do. So on December 12th, we make a change to the Lambda managed runtimes that will basically pull the hot patch in to mitigate the issue for customers. So this means that if you're vulnerable as a customer and you're running an affected version of Log4j, this change is patched for you automatically. This is also, for what it's worth, is unusual, and that's part of kind of how compute shifts, right? Is that it's not always the same. That how folks run in EC2 instances is not quite how things work for someone that's running Lambda or containers. And it was something I think that ended up being really important to customers, is even though the base configuration I got from you folks doesn't have Log4j, I'm still impacted. And we can't just leave customers there because it didn't come from us, right? So on December 14th, another Log4j CVE. Actually, two. So the first one is basically that the original patch, spoiler alert, was not complete. In some non-standard configurations still. Security people love, by the way, saying non-standard configurations. It basically means out of the box, don't worry about it. But like, if you did this other thing, maybe. But basically, RCE was still possible in some non-standard configurations. And then, again, in some non-default configurations, if you were using JMS appender and someone had write access, RCE was still possible. AWS is not impacted by either of these because we blew away our friend the GND lookup class on day one, and because we included Log4j v1 from the beginning. This was good foreshadowing again, I thought, because by December 14th, the internet has verified for us that Log4j v1 was actually infected. Later on the 14th, we end up publishing that hot patch RPM. So we've produced basically a package that other folks can use of the internal hot patch. Amazon Linux 1 and Amazon Linux 2 are not impacted by Log4Shell out of the box, right? We didn't ship those versions of Log4j, but some customers do. So on the 14th, we published that RPM, so Amazon Linux customers can use it as well. On the 17th, it is our last and final for this exercise. Log4Shell CVE. So this is the last one. And this basically says that for some configurations, a denial of service, so a DOS, is possible through our friend from Computer Science 101, recursion. AWS is not impacted. So on the 17th, Amazon Linux, so 1 and 2, start applying the hot patch by default to installed JDKs. And then we publish an apt repo so that folks using Debian or Ubuntu can use it as well that aren't on Amazon Linux. And that, I think, is kind of the end of our initial response, right? So we've had 5 CVEs. We've started basically uncountable numbers of parallel threads for deployments and hot patching and regular patching, leadership updates and customer messaging. Whew. So what went well? What didn't go well? So starting with the bad, there were some less successful elements here. So the first one is, as we were kind of figuring out how to get these changes rolled out for teams, there were some rocky bits, especially in terms of communication. So namely, if you were just a team receiving a ticket and you were seeing the public information around additional CVEs, we didn't do an amazing job internally publishing, we're not impacted, we're not impacted, we're not impacted. And that made the response a little tricky for service teams as they were trying to parse that information that came through. On the external side, we were inconsistent with providing our customer messaging. We got a little distracted by the internal work, and I think we were a little slow getting customers, some of you might have noticed, in getting some customer bulletins out around what services were impacted or not, or as a customer, what action you had to take. We had some rollout snags with the hot patch, so those latency blips for Lambda. And we briefly covered this, but deploying things on behalf of teams is really unusual for us. And that definitely caused some confusion for teams as they were trying to figure out, well, but if you're rolling out the hot patch, do I still have to do things? Do I still have to patch? Do I still have to deploy? How do those things work together? And lastly, our tickets often went right to service on calls. And those folks weren't necessarily familiar with Log4Shell. They weren't necessarily folks that usually responded to security issues. A lot of them generally get paged for things like operational issues. Your service is returning some weird errors, right? And in a lot of cases, we know now that we should have gone directly to people like principal engineers or managers, right? So the folks that those on-calls ended up having to escalate to, we could have gone straight to them. But there were some really, really cool wins here on top of that. So the first one, right? Ryan removing the entire JNDEET lookup class and assuming that log4j-v1 was affected from the beginning, huge win by Ryan, right? That was incredibly smart and also paranoid and delightful. So a big thanks to Ryan on that one. This is my not to scale illustration of what defense in depth looked like. But I was really proud of how defense in depth ended up working for Log4Shell here. We had both the hot patch, the regular patch, things like those WAF traffic filtering rules, and then we had the proactive blocking of potential exploit attempts. The hot patch from Volker, incredibly cool. I think not just for us, but for a lot of the folks external to AWS that also ended up using the hot patch. Really cool. And a big game changer, I think, if patching is hard, which it is in a lot of places, being able to patch that running JVM was a big win. 4, builder tools held up pretty well. This is an unbelievably massive amount of build deployments, right? Which means an unbelievably massive amount of load in the build systems. And some proactive thinking from the builder tools teams around things like scaling up in waves really made some of this possible. And finally, this required hard work from thousands of teams during a really particularly tough time of year. Folks want to go on holidays, their kids have holiday concerts, they have vacations planned. Log4Shell is not necessarily compatible with vacation plans, but nothing gets you in the holiday spirit like a 0 day. More generally, what did we learn about what works and what didn't work? So the first, engage our leaders early, right? So we know that Ghostbusters is a senior group, and we're kind of leading with that from the security side. But on the service team side, so on the folks that own those pieces like EC2, engaging them early was the right call. 2, we know that we have to over-communicate, and we have to communicate much more and much more often. We have to work backwards from what we can do for teams. So what work can we do centrally so that teams don't have to do anything? If we had asked teams to do every single piece of work here on their own, it would have been an incredibly, incredibly large spend of resources for something that was already very expensive. So the more that we can do for them to make it easier, the better things end up going. 4, you have to have a plan for the whole long haul. So in this case, that means things like, when do people sleep? When do people eat? When do people get a chance to sign off offline and bake cookies or go to the gym? I don't know, right? But you have to have a plan for how to not burn people out in the first couple of minutes or the first day. And then lastly, you need who you need. It's okay in this case, right, to go straight to senior engineers. So to page people's principal engineers, that's what they're for. Or to page senior leadership, right, like the general manager of a service. When things are really important, you just go straight to who you need. We're all here to be paged. We're all paid to work on these services. So you just go straight to who you need. And 6, you have to be flexible, and you have to iterate quickly. And you have to be ready to kind of move on the fly and to be flexible and to do things like start rolling out a hot patch. By the end of this exercise, we wrote around 6 separate retrospectives for how Log4Shell went, right? So everything from that initial incident response to how well the build tooling performed to what we could have improved in our analysis. And finally, before I let you folks go, this would not be a Log4Shell talk without acknowledging the incredible dedication and hard work from thousands and thousands and thousands of AWS teams. This was a tough one. I know that it was a tough one for customers too. And none of this would have been possible without the hard work from a lot of folks. That is all. Thank you for joining me on this last day of reInvent. We won't do questions on the recording, but I'll hang out for maybe five minutes at the back of the room if you want to ask any questions. And I am contractually obligated to tell you to please do the session survey on how much you love a Friday 10 a.m. session. That is all. Thank you very much.